In this tutorial, you'll learn how to create personalized container images using Dockerfiles and launching containers from your custom creations. Let's understand what is custom containers. Custom containers are tailored, purpose-built environments crafted to meet specific requirements, providing a lot of advantages. Optimized resources. Custom containers allow you to streamline the inclusion of only essential components, minimizing resource usage. This optimization ensures efficient utilization of system resources and reduces container size. Application specificity. Tailoring container images enables precise configuration for your applications. You can include specific dependencies, libraries, and configurations, ensuring seamless compatibility in optimal performance. Enhanced security. By crafting containers with only necessary components, you reduce the attack surface, enhancing security. Custom containers empower you to implement specific security measures tailored to your application's needs. Efficient deployment. Custom containers are designed for your application's unique requirements, facilitating faster and more efficient deployment. This targeted approach eliminates unnecessary overhead, accelerating the containerization process. Version control and reproducibility. Dockerfiles for custom containers serve as version-controlled blueprints. This enables precise replication of environments across different stages of development, testing, and production, ensuring consistency and reproducibility. Cost efficiency. Customizing containers allows for cost-effective resource allocation. By excluding unnecessary components, you optimize infrastructure costs and improve overall operational efficiency. Flexibility and scalability. Custom containers offer flexibility, allowing you to adapt containerized applications to evolving needs. This scalability ensures that your containers can seamlessly grow or shrink based on demand. Step 2 is to create sample Python application. In this sample Python application, we will make use of Flask, a lightweight web framework for Python. It defines a basic web application with a single root that returns a "Hello, world" message when accessed. Import the Flask Python library. The Flask class is used to create the application instance. The if __name _= _main ___ block ensures that the Flask application runs when the script is executed directly. The app run, host equals 0.0.0.0, port equals 8080, line specifies that the application should be accessible on all network interfaces, 0.0.0.0, and listens on port 8080. The app root / decorator associates the hello_world function with the root URL. The hello_world function returns the hello world message. Step 3 is creating a Dockerfile. A Dockerfile is a script-like text file that contains instructions on how to build a Docker image. Let's create a Dockerfile. Select a base image. Begin by choosing a suitable base image that aligns with your application's requirements. Base images serve as the starting point for your custom container. For example, You can use Alpine Linux for a minimalistic approach or a distribution like Ubuntu for a more feature-rich environment. Define maintainer information. Optionally, include information about the maintainer of the Dockerfile. This helps in identifying and contacting the person responsible for maintaining the container. Set the working directory. Specify a working directory within the container where subsequent commands will be executed. This simplifies the file structure and organization within the container. Copy application files. Copy the necessary files from your local machine to the container. This includes application code, configuration files, and any other required assets. Install dependencies. If your application requires specific dependencies or libraries, use the appropriate package manager to install them within the container. Expose ports, if applicable. If your application listens on specific ports, use the expose instruction to inform Docker about the network ports that should be exposed. Define default command. Specify the default command that should be executed when the container starts. This can be the main application or an entry point script. Save the Docker file. Step 4 is building a custom container image. Build the Docker image using the Podman build command. Podman build followed by -t, which indicates the tag you want to add to the image, followed by period, which indicates the location of Dockerfile. We observe the image being constructed with the instructions outlined in the Dockerfile. Each layer aligns with the respective instruction in the Dockerfile. Let's list images to see our custom image. Something seems wrong, tag and repository are none. We will build again. Oh, the image is not successfully built. There is an error log stating build failed at 7th step of Dockerfile. Let's look at the Dockerfile and rectify the step. And build again. We see the image is built successfully now. Step 5 is launching containers from custom images. Now let's spin up our custom application container using our custom image by executing Podman run command that we learned in our previous tutorial. Our custom container is up and running now. With a solid understanding of Dockerfiles and image building, you're well prepared to venture into the realm of container customization. Thanks for watching. Subscribe for more content.